Okay, good morning. We are now delving a bit more deeply into those four important tracks that we have previously discussed. Just to reiterate, you have three ascending tracks and one descending or motor tracks. We're going to discuss them in a little bit more detail. And right now, we're going to talk about the anterolateral system. You might encounter there's this term in when you are reading your textbook, and it's nice that we discuss it so that you would know what people are talking about when they say anterolateral system. So let's begin. Now, when you say the anterolateral system, just keep in mind what you're talking about is mainly the spinothalamic tract. Okay, and when you're thinking about the spinothalamic tract, the the primary modality that immediately jumps into your mind is pain and temperature. Okay, pain and temperature, and then you add crude touch. Okay, pressure, crude pressure, and just to elucidate further, your spinothalamic tract is actually there's actually two distinct spinothalamic tracts. You have your anterior and you have your lateral. That is why they are called anterolateral system. So it all makes sense now, right? Lateral. So that's your anterolateral system. Basically, all you're saying is it's the spinothalamic tract in detail. Okay. So again, just to reiterate, let me bring this up. Okay. I've shared this picture to you before. So just to start off, you have your pain or temperature or crude touch receptor. Okay. That's your sensory nerve. That's your dorsal root ganglion, and it goes into your posterior horn. Now, once it's in your posterior horn, let's continue here. It goes here in your substantia gelatinosa. Okay? When you're talking about the anterolateral system, pain, temperature, crude touch, the thing that you should remember is substantia. And this term will be very familiar in your whole career. Gelatinosa. Okay, so it synapses with this part of your posterior horn, and then it goes up there. Okay, so it goes up one or two levels, and then it crosses. Okay, and then it goes up, synapses with your thalamus, and then it synapses with your pre or post central gyrus. Why? Because it is your primary sensory. Makes sense now, right? So if you draw your brain like that, you have your central sulcus. It's going to be right here, posterior. Okay, so it all falls into place. Now, remember last time, there's a name for this tract, the spinothalamic tract that goes up or down one or two levels and then crosses. Before it crosses, it's called your Lissauer's tract. Not very important, but good to know. Sometimes it might crop up in quizzes, but it's just nice to know. Not vital to your career. Anyway, another side note, your anterior and your lateral spinothalamic tract, there's a difference with the type of sensory modality that they're carrying. Your anterior spinothalamic carries crude touch, or, well, general pressure. And then your lateral is your pain and temperature. So if you're talking about the classic spinothalamic tract, it's your lateral. But, well, your crude touch is also very important. Okay, just take note, if somebody punches you in the face, that is not crude touch. Okay, now, we are going to talk about one more term, this part over here. You might encounter the term spinal lemniscus. Okay, the term lemniscus is going to be discussed many times. Okay, or you're going to hear about the lemniscal system, or you have your spinal lemniscus, you have your dorsal or medial lemniscus. So what is it? Just remember this, it's a tract, okay, or a group of tracts. And usually, number one, it's sensory, okay, and there's, well, at least two basic important lemniscal systems. But when you're talking about your spinothalamic tract, this part here, after it has crossed, it is called your spinal lemniscus. Now, your spinal lemniscus is not simply your spinothalamic, it's a group. Okay, so we're going to enumerate the group. Okay, you have your anterior spinothalamic tract, you have your lateral spinothalamic tract, you have another ST, spino or spinotectal. Okay, your spinotectal tract is an interesting tract. You see it frequently in horror movies, and this is how you do not forget your spinotectal tract. Your spinotectal tract is a protective mechanism. When somebody behind you touches your shoulder here, what do? Do you turn the other way, or do you turn in the same direction as where you felt the stimulus? Okay, basically, where you felt the stimulus, you felt a draft of cold air as you entered the haunted house, you turn where it is. You see something move in your peripheral vision, you turn where it is. So basically, that's your spinotectal tract. No idiot Neanderthal ever survived if he turned the other way. Okay, that the thing that he sees in his peripheral vision just might be an incoming rampaging woolly mammoth, and if he turns the other way, he is dead. Now, your spinotectal tract, I'll just draw it in dotted form. Remember when we talk about the midbrain, you have four round bulges at the back of your midbrain. We call it your colliculi. Colliculus. Okay, you have your superior, you have your inferior. Your superior is mainly vision oriented, right? What you see, or, well, a little bit more what you touch. Inferior is auditory, okay, tone or whatever. So your spinotectal tract synapses with your superior colliculus and then goes up. Okay, so that's your spinotectal tract. It's a nice protective mechanism. So you now see all these structures coming together. And when you talk about the spinotectal tract or spinotectal tract, just think of horror movies. The last would be spino-reticular. When you're talking about the term reticular, you think about the RAS, your reticular activating system. Okay? So when you think about this, you think about wakefulness. Okay? Meaning arousal or the system that makes you awake or makes you sleep. So basically, if your limbs are moving, your basically that those are the um, impulses or the stimuli that basically stimulates your reticular activating system. It stimulates you, keeps you awake. So this is your anterolateral system, your spinothalamic, anterior and lateral. And then we just discussed your spinal lemniscus system or spinal lemniscus, which is a group of tracts, and these are what makes it up. So I do hope you now have a nice orientation or nice appreciation of your spinothalamic. Now, one last thing, let's go to your gait control. Because this is very important when you are dealing with pain in your patients. Gait control theory involves your, let's draw your gray matter, okay, in your spinal cord. Remember, it's like this. This is your substantia gelatinosa, okay? So when you're talking about pain, temperature, crude touch, they synapse, okay, this is your dorsal root ganglion, they synapse in your substantia gelatinosa. And just a side note, your substantia gelatinosa is actually continuous with your trigeminal, your sensory part of your trigeminal nuclei in your brainstem. Okay, so that's a very important thing. Well, not extremely important, but a nice fact, and it ties your body and your face together. So when you're talking about the substantia gelatinosa, the term gait control theory or gait control is also thrown in. And what is it? So for example, you got inside the Jeep and you're not careful and you banged your head in the roof. Okay, so it's really painful. What do you do? Basically, you usually have two options. Option number one is immediately you do this. Okay, or why do you do this? You notice that basically it helps with the pain, right? It helps with the pain. Now, the second option is, of course, if you want to look cool, you just bang your head. People are all looking at you. Your option is to just hold the pain, play it cool, don't do anything with a straight face, just sit down and pretend you're not dying from pain. Now, which one is better? If you want to look cool, the second option is better. If you want the pain to go away, you do this. Why? You're basically employing your gait control theory. So basically, your gait control theory states that if this is your substantia gelatinosa, if you have a pain impulse coming in, basically you have two types. You have slow pain, okay, that's your C fibers. C fibers are small, unmyelinated. They are slow, okay, that's why they're called slow pain. And then you have fast pain or fast mechanoreceptors, touch, crude touch. They're carried by delta fibers. They're bigger and they're myelinated. Okay. So if it's myelinated and if it is big, you're talking about faster speed. So when you break something and you and your sibling together broke it, what do you do? Both of you run to your mother, and the faster one who gets to your mother fast is the first one who could give his or her version of the facts before the slower one, and thus theoretically save yourself. Now, your gate control theory says that you have your slow pain. That's what you felt when you hit your head on the roof of the jeepney. So it's going to go up to your thalamus, right? But if you also do this, now that's your fast mechanoreceptors impulses from your mechanoreceptors. That's your fast pain. Once they arrive at the substantia gelatinosa, faster fibers sort of block that slow pain, and they're the ones that go to your thalamus first. They block the slow pain, and so your thalamus sort of prioritizes the sensation from your fast pain fibers. So that's why when you do this, when somebody bonks you in the head and you do this, basically you're employing that gate control. You're shutting down the impulses from your slow fibers, slow pain fibers, and you're basically masking the pain. So that's what you call pain masking. Okay? So when you get a jab from your vaccination, it's painful. What do? You rub it. It helps. That's basically your gate control. Okay, so that's your anterolateral system. Okay, so um, just review, understand. It's not very hard. It's actually pretty easy, pretty logical. And I do hope you'll understand it enough for you to use on your patients later on in your career. So that's all for now. We'll meet again when we discuss your dorsal columns. So thank you.